Right, this is our last example for Unit 2, and we're going to find the equation of this function over here. The graph below shows y equals the absolute value of a function. So as soon as I see it's an absolute value of the whole function, I know it has been reflected in my x-axis. And they've told me that my original function was a quadratic. Now that kind of makes sense because if I have a look here, this part of my function has been reflected, so it means that the original function looked like that. Okay, so I know what the original function looked like. Let's see if we can figure out what the equation for this specific graph is. Okay, now we've been told that our original function was a quadratic, which is good because we can use that information to help us to find the form. And because I've been given x-intercept, it makes sense to use x-intercept form. Okay, so let's go. In the form, y is a x minus x1 x2. I've got x-intercepts at 3, 0 and 6, 0. So therefore, x1 is going to be equal to 3 and x2 is going to be equal to 6. Okay, so I have a thing in the form y is a x minus 3 x minus 6. And the only thing I really need to know there is my a value. And I've been given another 0.72. So using 7.2 to determine the a value, I have 2 is a, 7 minus 3, 7 minus 6. So that's going to be 4 times 1 is 4. And so a is going to be a half. So my original function would have been y equals a half x minus 3, x minus 6. But I'm looking for my absolute value function, okay? So I've been told that y is the absolute value of that function. So therefore, my equation is going to be y is the absolute value of half x minus 3, x minus 6. All right, the next part of that says, find the coordinates of P and Q. And now we're going to use this absolute value function that we have developed. So let's start with Q. It's probably the easiest for point Q. It's my y-intercept. And that happens when x equals 0. So my function is y is the absolute value of a half x minus 3 x minus 6. And so I'm going to put x equals 0 in there. So it's the absolute value of a half times negative 3 times negative 6. And 3 6s are 18, so it's divided by 2 is the absolute value of 9, which is just 9. So my point Q is going to be at 0 and 9. Okay, to find P, well, I know that it's symmetrical. The x value will be symmetrical halfway between my x-intercepts. So I guess I can start with that to get my x value, and then I can use that to find my y value. So for point P, and I'm going to say using symmetry, and halfway between 3 and 6 is 4.5. So P of x is 9 over 2. And I'm going to substitute Px, my x value of P, into my equation. To get my y value. Okay, so P of y will be 9 over 2 minus 3, and 9 over 2 minus 6. And that's going to give me the absolute value of a half. So 4.5 minus 3 is 1.5. 4.5 minus 6 is negative 1.5. We're still working with absolute values here. And that's going to be the absolute value of negative 9 over 8. But because we want the absolute value, that's positive 9 over 8. So therefore my point P is going to be 9 over 2 and 9 over 8.